So you've already taken graph sum, right? I mean, it's a data structure in which you have a set of nodes or vertices, and you have a set of edges between them, and the edges could either be directed or undirected, and right. So it's an edge is a pair of nodes, vertices, and there's lots of applications. You can be how the computers are hooked together, or how roads are hooked together, or how people in Facebook are friends or not, right? And following is a directed edge, while in Facebook, friends is an undirected edge. So you can have the various words like an edge is incident to a node, adjacent. Two of Joes are adjacent if there's an edge between them. The degree of a node is the number of edges coming in. You can have in degree and out degree. Parallel edges. I've never seen parallel edges before. Oh, I see. If they're going between the same. Most graphs don't have parallel edges, but there you go. Self loop. And then a path is a sequence through here, right? I think we've done some of this already, right? And a cycle is the path that starts and ends at the same place. You can prove various theorems, which we don't need to do. And then this course is about data structures and software engineering. So there's the various obvious operations you can do. I mean, basically, if I was going to be doing a graph theory algorithm, what are the operations I would want to be able to do? I'd want to be able to sort of go through the nodes in some order if I wanted, go through the edges in some order. If I have a node, I want to know which edges are adjacent and who my neighbors are, right? The neighbors are nodes that have edges too, right? And you want to be able to then walk, I have a position or a pointer at one node, and I want to say, follow this edge and get to this other node. Right? So then you can think about how to store it in a data structure. And the one way is you have a matrix with a row for each vertex and a column for each vertex. And then you have an edge for each entry, right? And you'll note that this matrix is symmetric. Like you can flip it, that the VU entry equals the UV entry, right? And that's because the edges are undirected. If they were directed, then it wouldn't be necessarily symmetric. Called an adjacency matrix. You could also have a linked list of the nodes, and so I guess here U has an edge to V, so you can have each node have pointers to its neighbors, right? Right. So here U has a pointer to V and to W. If you want to. Right. So you can have whatever data structure you want for storing the vertices, right? And then each vertice could have a list of its edges that it's adjacent to. Here you can have any data structure you want of the edges, and then each edge can point at the two nodes that it's adjacent to, right? And so those are all various I don't think we need to say much more. I mean, it's all pretty straightforward, right? So a subgraph is you take a subset of the nodes, and then you only, you throw away edges if you've thrown away their nodes. A connective, a graph is connected if there's a path between every pair of nodes, right? These guys aren't connected. A tree has no cycles. A forest is a disconnected set of one tree is kind of assumed to be connected, right? So a forest is not connected. And this tree isn't rooted, right? So if you grab any of the nodes and you shake it, then it becomes rooted. Yeah, for an undirected graph, it's really clear that if there's a path from U to V, then there's a path from V to U, right? And when you have directed graphs, that's not the case, right? And so it's strongly connected if for every U and V, there's a path from U to V and from V to U, right? You can get there and you can get back. And then if you want to get nuanced, we could find other definitions connected, which we don't want to do. Yes, let's go with that. I would say normally when I would say connected, I would think it's an undirected graph. Because when it's directed, then I have to think about what do I mean by that. A spanning tree is a subset of the edges that spans the graph, meaning if it was connected, it's still connected.